Morning Shot.
Good morning. Thanks for tuning in to Money FM 89.3. I'm Lynlee, bringing you your morning shot today. A team of local scientists have just developed a new green cooling system that could potentially reduce more than a quarter of energy costs and carbon footprint of data centers. Now, this breakthrough comes at a time when data centers are becoming more crucial than ever due to a global spike in the demand for cloud computing. And such centers actually come at a significant cost as they consume high levels of energy. In Singapore, data centers alone account for about 7% of the nation's total electricity consumption currently. So, how much can the latest green cooling invention help? To put that all in perspective for us, we're joined by its project lead, Associate Professor Wong Neng from the School of Mechanical and Aerospace Engineering at Nanyang Technological University of Singapore. Good morning, Prof.
Yeah, good morning to you. Yeah.
Okay, first off, Singapore is poised to continue leading as Asia's key data hub. Now, keeping that in mind, how high could our energy consumption rise in the next decade?
Now, Singapore being a data center hub for Asia-Pacific region and already account for around 360 megawatt, which is about 7% of the national total electricity consumption, is projected to expand our data center footprint and to meet the growth demand. So in doing so, Singapore is also looking for more sustainable way to reduce overall energy consumption and carbon footprint for data center.
So, jumping into that spray cooling method that your team invented, how does it differ from more conventional cooling methods in terms of results and perhaps convenience?
So unlike the conventional air cool system, we have developed a spray cool system that allows data center cooling to operate in a tropical climate condition without the need of the high energy demanding chiller bay cooling system. And that reduce the energy requirement and that also lower the operating temperature. So what we have done is we use a non-conductive liquid is used to spray and cool directly for effective heat removal using the principle of evaporation, boiling, and droplet impingement that can remove heat enormously. Then after that, the vaporized coolant is condensed back by liquid to a condenser coil, and after that, recirculate back to the system. The condensing coil is cooled by room temperature water, which is supplied at 30 degrees C, and we are able to maintain the CPU, which is at a lower operating temperature. So that means that we can eliminate the need of the chiller, and with that will result in about 26% saving in the total energy consumption.
Okay, how minute are these droplets and how do you actually supply that infusion of cooling droplets?
So what we have done is we pump the non-conductive liquid pass through a nozzle, and the nozzle will atomize the liquid into fine droplet, and that fine droplet traveling at slightly higher velocity and use it to impinge on the hot surface directly. So on the surface itself, there will be evaporation, there will be boiling, and there will be droplet impingement. So that can remove heat enormously from the heated surface like CPU. So by doing that, we do not need a conventional heat sink that are used to attach on the CPU to draw heat away. So we have removed the heat sink and perform that part of the cooling system.
And how will this actually translate into higher efficiency for data centers, as what your team has claimed?
So because of the CPU are able to operate at lower temperature without the need of the chiller, and this spray cool system also allow this IT load density to at a higher IT load density, because it increased the heat rejection capability, and it also allow higher computational performance per unit space. So that will result in about 30% saving in the floor space as compared to the conventional air cool system.
Okay, so saving space, which will allow for higher computing power servers to be packed into a smaller space. Is that what you're saying?
That's right. So which means to say you can have a much higher power server, and that can be packed in a smaller space. That will result in 30% saving in the floor space.
All right. So, what are the challenges that this invention does not solve?
So we have developed a lab prototype which have the capability to have a power usage effectiveness of about 1.08. So PUE that we call, or we say power usage effectiveness, in fact, it is a ratio of the total amount of the power consumed by a data center versus the power used to run the IT equipment. So the closer the number to move to one, the more efficient will be the data center. So our spray cool system can go as low as 1.08. So that result in energy saving as compared to the conventional PUE, which is around 1.7, 1.8. So the prototype is ready. So the next phase of the development is to sit to work with our industrial partner to develop a larger pilot plant, which can demonstrate the potential of that. But that largely depends on the partnership between industrial partner and the resources that we can have, and so that we can fine tune and do that scaling up.
So, speaking of which, how do you envision that scaling up to look like? What will determine its level of success from an industry point of view?
So currently, we are still working on sort of looking forward for that we can showcase that potential. So as I said, the prototype is ready, but the next phase is to seek further collaboration with industrial partner that we can bring this thing to the next level.
Apart from data centers, which are the other potential industries that could adopt such an invention?
So the technology are able to dissipate high heat dissipation. So high performing gaming computer, high power electronic, IT equipment, IT power semiconductor devices with communication device. Because spray cooling have an ability to remove higher heat. Currently, cooling seems to be a limit for all these IT component performance, because as the device running at higher speed, it generates a higher temperature. So the ability to remove heat quickly, I think will have a lot of potential in cooling of higher power electronic devices.
Okay, taking a step back, what kind of factors must be looked at to determine the fine line of balancing to ensure that we manage to reduce our energy consumption as a whole, while still, trying to be that data hub that we want to be?
So I would think we need to look into carefully about the higher energy consumption, develop using technology to develop a much better efficient cooling system. They are able to remove to cater away increase the IT load density, remove away the heat. I think that will pave the way to faster and more efficient data center in future. So I think industry is looking for more better or innovative solution to resolve this problem.
All right, thank you very much for your time this morning. We've been speaking with Associate Professor Wong Neng from the School of Mechanical and Aerospace Engineering at Nanyang Technological University of Singapore. Thank you, Prof.
Yeah, thank you very much. Yeah, thank you.